Welcome to our next video on the quadratic equation. In this one, we're going to be focusing on the vertex form of the quadratic equation. The vertex form of the quadratic equation has the following form. A times the quantity a minus h squared plus k. That x squared term really is there, it's just a little bit hidden. So it's this here which lets us know that eventually we are going to get an x squared termed out. Let's move on to graphing. The a stuff is still the same. And it's still going to tell us in exactly the same way, open, up, or down, and its width. So I'm going to move on from there. The next thing to consider is our vertex. Now, as the name implies, it's going to be really easy to find our vertex. Our vertex is actually the ordered pair h, k. H and k come right from our equation. Important note here, just like in the standard form, you got to be really careful about your signs when comparing your general form, which is this, our general form, and a specific form. So let's create an example. Well, you can do y equals x plus 3 quantity squared minus 2. So here, we need to be careful when determining the sign of h and k. So let me line up this general and specific. I'm starting off with my specific form, and then let me write out my general form. Now, let's break it down. Here I see a is going to equal 1. Easy enough. Now I need to consider h. I've got plus 3 and a minus h. The signs don't match, so I need to consider the following. It is in this form. If I said h equals 3, this is what would come out if I stuck it in here. I would have x minus 3, but that's not what we wrote. Instead, let's consider if h equals negative 3, I would have x minus a negative 3, which can be rewritten as x plus 3. So when the signs don't match, h is actually the opposite value. Same advice goes for k. Consider, it's supposed to be plus k, and we have a minus 2. If I were to have plus 2, that doesn't match up to what's in my specific form. If I were to have plus a negative 2, I can simplify that to just minus 2. So this is what k equals. And this is what h equals. Be careful here. We know our vertex comes from h and k. H is minus 3 and k is minus 2. Our vertex is now easy to find. X, our x coordinate comes from h, which is negative 3, and our y coordinate comes from k, which is negative 2. Lastly, we consider the axis of symmetry, and this is the x coordinate of the vertex. So in this case, it's x equals negative 3. I still got to consider a. A is equal to 1 in this case, which implies it opens up, and it's the same width as x squared. So now I can move on to drawing it. My x-axis, my y-axis, my vertex point, if I scroll down, it's negative 3, negative 2. It opens up, and it's the relative width of x squared. So to summarize, consider the effects of a, whether it'll open up or down, and its width. Find the vertex using the information provided by h and k in your equation. Be careful of your sign. And the last thing that I forgot to draw, your axis of symmetry is the line of x equals h. In this case, axis of symmetry is x equals h, and it was, for this specific problem, x equals negative 3. So our axis of symmetry is the vertical line x equals h. I hope you found this video helpful. The next video will focus on the intercept form of the quadratic equation.